Hey math friends, today we're going to look at the greatest common factor and how to find that between a set of two numbers. So essentially we have three easy steps. Number one is to create factor trees. Number two is to identify common prime factors. And then from there we multiply the common prime factors. Let's look at some examples, and as we do more and more, they'll become more fluent to us. The first example says, what is the greatest common factor of 16 and 28? So what we need to do is make factor trees. So when we make factor trees, we want to know what numbers times each other get to 16. So it's an even number, so I could use 2 and 8. 2 times 8 is 16. Okay. Now I need to remember about prime numbers. So 2 is a prime number. If you're not sure, you can always refer to a prime number chart, and that can help you out with this. 8 is not a prime number, so I need to think of two numbers to multiply to get 8. And remember, we do not want to use the number 1. So I'm going to use 2 and 4. And again, 2 is prime. 4 is not prime. 2 times 2 would be 4. I like to circle the prime numbers so that I know that I don't need to make any more branches on that part of the tree. So at the end here, I'm going to go ahead and write my prime factorization. So 16 equals 2 times 2 times 2 times 2. And we're going to count just to make sure there's 4 2's here and there's 4 2's here. Also, if you go ahead and multiply this, 2 times 2 is 4, times 2 is 8, times 2 is 16. That can help you make sure that you got that correct. All right, so let's go ahead and do the same thing for 28. So for 28, again, it's an even number, so I can divide by 2. That's a good strategy to start with sometimes. So 2 times 14 would be 28. So 14, 2 times 7 would be 14, so I can use 2 and 7. 2 and 7 are both prime, so we circle both of them. So now I'm going to write my prime factorization for 28. So 28 equals 2 times 2 times 7. So now we'll go to the next step, identifying common factors. So I'm going to identify the things that are common in both of these. So in 16, I have a 2, and in 28, I also have a 2. I'm going to use some different colors here to make sure that I'm identifying things correctly. There's another 2 in 16 that'll pair up with this 2 over here. Okay. Now it might look like we have two 2's again, but these are only for 16. There's no more 2's for 28. 28 has a 7, but 16 does not. So at the end, we're going to see our greatest common factor, or our GCF. We're going to take the things that we had. So in purple we had a 2, and then in green we had another 2. Those were the only common factors. Multiply them together, and we get 4. So our GCF for these is 4. I usually like to circle my final answer. Final answer is 4 for that one. All right, let's look at a couple other examples for this. What is the GCF of 27 and 81? If you need to use your calculator to help you, I would take that out and do like 27 divided by 2. Obviously that doesn't work because it's an odd number. Remember, we only want whole numbers here. So if I do 27 divided by 3, I end up with 9. So 3 times 9 is 27. 3 is prime, so I'll circle that. 9, the only way we can do that without using 9 is 3 times 3. All right, and 3 is prime, so I have 27 equals 3 times 3 times 3. All right, and let's go ahead and look at 81. 81 you might know as being 9 times 9. If you do, I would start there. If you don't, that's okay. You can start with 3 and go from there. However you start these factor trees, they're going to end the same way. You're going to have the same primes at the end. So 3 times 3 would be 9. Those are both prime. And for 9, I'll also have 3 times 3. That would be 9. Alright, so for 81, we're going to have to list all of these. So 3 times 3 times 3 times 3. Alright, and then we'll go ahead and do our GCF. So let's go ahead and we're going to go ahead and identify the common factors here. So for 27, I'll do this in blue. I have a 3. For 81, we also have a 3. I'm going to switch to red. For 27, there's another 3, and that pairs up with this 3 over here. All right, I'm going to go with purple now. So I have a 3 here, and I have another 3 over here. Unfortunately, this 3 over here doesn't pair up, but I did pair up a whole lot of them this time. So I'm going to go ahead and write my greatest common factor, or GCF, equals, and we had the blues pair up with 3, the red ones were a 3, and then the purple was another 3. Okay, so then I'll go ahead and multiply 3 times 3 is 9, times 3 is 27. So the GCF for this one is 27. It can happen that your GCF is one of the original numbers. So sometimes that happens, not always though. All right, we have one more example to look at here. What is the GCF of 14 and 21? So let's go ahead and see. We have 14. That would be 2 times 7. Okay, so those are both prime. So I just have 14 equals 2 times 7. That's the only way to do that. Remember, the order doesn't matter here because of the commutative property of multiplication. We could do 2 times 7 or 7 times 2. 21, there's only one way to do that. It's 3 times 7. Remember, we say there's only one way to do each of these because we do not want to use the number 1 when we're looking for prime factors. All right, so 21 equals 3 times 7. Then let's look for common factors. I see a 2 over here, but I don't see a 2 over here. I see a 7 over here, and I do see a 7 here. So I'm going to go ahead and make sure I have those marked. And that's really the only common factor. So for this last one, the GCF is simply 7. That's it. All right. We hope that helps as always. And thank you for watching.